He saw that and he said, "You can really do this?" And I said, "Yeah, we can do this." And that's what sold the project, and that's what got it started.
Hey, welcome back, YouTube. All right, so last time we talked about the fundamentals of what the data you're getting from nolimits is and how you can use that to understand what you're getting. And today we're going to dive right into how you take this data and make a 4D coaster. So you can be as cool as Alan or, Arrow or whoever you want to be. But today's episode is specifically for the 4D coaster and how you can use this data to model track that would be like a 4D. So, being the teacher I am, I made a little PowerPoint presentation to walk you guys through what we're going to be doing today. As you can see, this is just a snapshot from nolimits, and we're going to take a look at, think about what the data is that we're taking out and how we're going to apply that data and recreate what you see in front of you here. So, like we said last time, we're going to get a position, an X, Y, and Z, and we'll be able to create our rails like we've done in past videos, by doing left X, Y, and Z, multiplied by some distance, which in this case will be our rail gauge, divided by 2. And then we can do the same thing on the other side for the right rail, which would be a negative left X, Y, and Z times whatever scalar that is. And we're going to add that to our position X, Y, and Z. And that's how we'll get our rails. So then, from there, how would you go and get the next thing? Which, let's just start with the spine. Which is actually straight down. So to get your spine location, you're just going to do the same thing, only with your up X, Y, and Z. But since it's down, remember this is up, we need to do negative times whatever distance from the center of rails to wherever your spine is going to be. Okay, following? Okay, hope I didn't lose you. Now, we have these guide rails on the side, and this is what the rack and pinion is actually moving against. And before we start doing the math to figure out the rack and pinion, we're not going to really do that in this video. We're just going to show you how to set it up, and then you can figure out on the side how you gauge that. So first, you're going to go down for both of them, and then you're going to go to the left and right, respectively. And that's what you see here. And you're still using the same data that you got from nolimits, and we'll revisit this, and you can take a snapshot of this to then figure out how you're going to go model it. And this actually would apply for any type of track section. But this is just like the nominal, right? You want to be able to adjust it. Well, that would then need whatever your rotation travel, whatever that distance is, which you'll figure that out in the math with the rack and pinion. And then you just multiply it by your up, because you need to go by up, and then you just add that to the previous calculation. So this slide is insanely busy. And if you're lost, just take a snapshot of what you're looking at here. And then I'll kind of walk you through it in Excel on how we're going to create the curves that we can bring into our CAD space and model this. Hopefully I didn't lose you yet. Okay. So let's go into Excel. What I did is I created a track section. And I'm not going to dive too far into this, but you'll see from all those thousands of data points, I found I want to make a track section from 4,700 to 4,800, 21. That's because we went through 0.1 meters every bit of data. And we then brought that into Excel, and I'm saying, okay, I want a 40-foot track section just to make sure it fits on a 55-foot bed of a truck. And this should be long enough. And then what I did is I'm gonna only go by like 11 data points or so for my height travel on my rotational rails, so to speak. So that's why I only have a little bit, but you should still be able to do it. So diving right into it, first we need to figure out our rail gauge, and I'm just going to use the nolimits track centerline gauge, which I have 1.2. So let's do the same thing. And like I said, I'm just a teacher showing you kind of from my notes on how we're going to do this. So we're going to do rail gauge, and we'll do half of what we just read, right? So 0.6. All right. And if you've watched my other videos, you'll know that I like to start with the left and right rail and calculate from there. Now remember, from our diagram on PowerPoint here, we're going to do the rails, and then we're going to go and find the guide rails. We're also going to do the spine. Missed that, but we'll get to it. So for the left rail, I'm going to go kind of fast, and if you miss anything, just pause the video and take a look at what we're doing here. And what we're doing is from that image, so we're doing position X plus, in parentheses, our left X multiplied by our rail gauge, which is the magnitude. Remember, this left X and Y is basically a unit vector or a direction. And we got to do that for the Y and the Z too, to get our entire point. And then so we just take that across, as you can see, the equation, and then you just bring it all the way down. Ta-da. For the right rail, we're then going to do B2, which is your X position, and this time we're going to subtract, because we're going to the other side, our left X times our rail gauge, right? And then we're going to bring this across. And as you can see, as we go across here and we look at the equations, all we're doing is doing X, Y, and Z. We're doing the same thing, and we're making sure we keep our rail gauge the same. So that's why we have dollar signs, and that's just some Excel syntax there. So you should be able to follow that. And there you go, you got your two rails. So now let's jump into the spine. All right, so for the spine, just like the rail distance, we need to know what that distance is. And for this example, I'm just gonna pick an arbitrary number based upon what looks right. Like I said, you might wanna go check online. Heck, just go ask an actual park employee what that distance is. We're gonna just use 1 for this example based upon just, it looks kind of like a triangle, very close, might not be. And technically you'll have probably 2 together, so we'll just do 1 for this example and go from there. So spine, we're gonna do the same thing, spine X, Y, and Z, and we're gonna go take that from our PowerPoint straight down, so that's a negative up, so it's this equation right here, multiply distance and add it to our position. So just like we did with the rails, we're gonna have our equation that's gonna take our positive X, then subtract the up X, multiply it by our spine distance, which is 1. And then we're gonna bring that over, and that will give us our Y, which is using the Y position, and our Z using the Z position. And we're gonna bring that down. And now we have our spine. So right there, you already have like the generic, 3 points or 3 rails you need to build your track. But we're making a 4D, so we gotta keep going. All right, looking at our PowerPoint again, we have our left, our right, our spine. Now we need to have these, I call them guide rails or the spinning rails, whatever you want to call them, rotation rails. This is actually what spins the 4D coaster. And what we're gonna do is we're just gonna do what? The nominal. And what do I mean by nominal is, let's just go all the way to the bottom, as low as it'll get, and that'll be our 0 position. And then from there, we'll add on this rotational travel, which would be, some height based off of your rack and pinion gearing that you would adjust elsewhere, which I said we're gonna talk about that in another video, not here. This is just to model the track. So first, you're gonna get this up distance and left distance. And that distance is this one and that one, right? For this example, I just did some setup work, and it's roughly 0.8 and roughly 0.35 meters. That's not exact science. That's just, some ballpark, just so you can follow me. And then we're gonna make our nominal spin left and our nominal spin right. And remember, we're just gonna go to the bottom here. This is where it gets a little confusing. It's probably gonna be one of the bigger equations that we're working with. So let's see what we're looking at here. O2. So that's our left rail, because that's where we're starting from in our PowerPoint. And we're going to subtract K2, which is our up, minus our up distance, which is right here. And then we're going to add, so we're going to go to the left, our H2, which is our left, multiplied by our 0.35, which is our magnitude. And we're going to do that for the X, the Y, and the Z. And as you can see how we're working here. So it just follows X, Y, and Z, and then you bring it down. Remember, these all, like even if I go down here, these are always referencing these distances, right? And then we're gonna do the same for the right. So we're gonna get our equation here, and we're doing the same thing, only now our signs are a little bit different, right? Still going down, but now we're going to subtract because we can go the other way. And the other thing too is we're going from the right rail. So you got to keep that in mind. All right. So once we get that in, we can take this over and then bring it down. And now we have the nominal. Okay. So you follow me, hopefully. All right, we're almost there. So at this point, we are here and we need to get our actual travel. This, we're going to skip a couple steps, meaning outside of this Excel sheet, you're going to determine, at what track point, what rotation of turn the ride vehicle has to have. And for this example, I'm just going to show you how you would integrate those calculations into this track geometry. And what I did is, for the viewing example of this, track piece, we're just going to start at the nominal 0, which probably would have never happened, and we're going to increment it by 0.05 per cross tie or per section, since there's probably 11 cross ties in this track piece. And that's the calculation here, which not really a calculation, I'm just doing this to show you. You would need to, I guess, if I go to PowerPoint here, let's see if I go like this. Here we go. Now you probably see what's going on here. Yeah, you're gonna have some sort of, I just grabbed this from the internet, some sort of equation to figure out how much distance this rail needs to move to then rotate the car. We're not gonna talk so much about that in this video, but I'm gonna show you. Let's say we calculated it'd be 0 to 0.5, right? So that's up for another discussion. There'll be another video. But let's say we figure that out. We'll go on to the next step. Now, we're going to figure out the spin, which is, I call it spin. Spin left, spin right. That's the actual rail we will have on our track piece. And this equation is probably pretty straightforward. All you're doing is you're taking your nominal, and then you're adding whatever magnitude this is times by K2, which remember is your up. So you're just using your up, because remember those are always direction, and you do the same thing for the Y and the Z. That's what you do for L2, which L2 is your Y, and then M2, which would be your Z. There's M2. And then you bring that down. Now the only unique thing here is, remember, this is gonna follow, the dollar sign doesn't go to the top because you're not following that variable. Your variable is changing. So if you even code it, you would have this be a variable that changes per whatever rotation you need. And then for the right, you do the same thing. Set up the same way, boom. Only now you're using the right rail as your nominal, and you're pretty much doing the same exact thing from that right rail. Bring it over and bring it down. And there you go. Very exciting. We now have everything we need to design our 4D track section in whichever CAD program where you want to use. Excited? I am, at least. I hope you're as excited as me. All right, so let's dive into SolidWorks. Okay, so now that we have our data, we need to bring it into a CAD program. I like to use SolidWorks, and there's a cool tool called curves through X, Y, and Z points. And from here, you can browse a file. In this case, it needs to be a text file. And as you can see, what I've done is I've taken that data set that we've calculated, and I guess I can just do this live, just in a notepad. You can take this data based off whatever, like let's say our left rail, you just take it, copy it in, and then save it. So then it's in a text file that SolidWorks can read. Very easy. So let's bring in a rail here. So let's go browse. Gotta be a text file. Let's just do the spine. Let's see where we're at. Bring that in. We have all our data. It's in inches. That's a mistake. All right, let's try this again. There, here we go. Okay. To bring this data into SolidWorks, we'll grab our data and we'll throw it into a notepad. Why a notepad? Because that's what SolidWorks will read. We'll save this, and like you see, I've already done this just to save time, and you'll just save this as a file and in that directory, and that's this data set. So I'm not gonna do that again, but we can go and browse for these curves. So we're gonna do insert curve, browse, text file, spine. Open it up, and remember we're all in meters, right? So that's why we have the meters here. Hit OK, and there you go. There's your spine. So that takes kind of a lot of effort. I'm gonna go and put 5 rails in. Well, once if I just hit delete here and do import 4D. Oh, there they are. Look at that. That's pretty dope, right? Just kind of popped right in. These are all the rails that we just calculated. And I made a macro, which we will talk about in another video on how to make macros, to then input all the data. Basically, it's just taking this curve and selecting all these and then doing it all for you in one button. You can do this in Autodesk, you can do this in Solidworks, you can do this in pretty much like every CAD software, just set, you know, automating your design, right? So if you see here, let's see, curve 5 and 6. These are the nominal, just to show you what it'd be nominally. But you see how there's this other curve that's kind of just starting at the same point and drifting up? Well, that is our actual spin. So the cool thing is let's actually model some of the track that you can see everything that's happening. So let's just make all of our little, so like for the spine, we're just gonna take this, and I'm just kind of doing this on the fly. Nothing scientific. We'll just kind of throw in. I'm not even, I don't know, 0.4, 0.425. Sure. And we'll sweep it. Sweep this guy, sweep around this spine, linear center. And you could argue like, man, this doesn't look like any of the 4Ds I've seen. I'm just making it look like this one. No limits, use one spine. I can use one spine. And we'll do the rails. So we'll just go off this plane again. Convert this guy. I don't know, what do you think? How big should this be? How big should my rail be? I don't know. Is that too small? I should have prepared a little bit more on this. I should have been like, yeah, the rail, it's exactly whatever meters, or I think it's like, I don't know. Like I said, don't matter. And let's get our rails, and then we'll go do the others. So right now I'm just lining everything up to the same plane, the same cut plane. And we'll sweep it. All right. And then I guess for this demonstration purpose, we'll hide 5 and 6 because we're not going to use those. And then from this plane, we'll sketch, we'll get this curve because they all should be on here. And we'll do the same, it'll just also be 0.2 now that I can actually remember. Those might not even be right. It just kind of looks right, which is enough for me for this video. And we're almost there. Didn't want to do that. And there you go. There is your track section. That's a 4D that has all your rails. And the cool thing is, with those data points, you can even give that to a track manufacturer and say, hey, bend this tube to fit those points in space, and you will get these rails. And then you just got to put the cross ties on. Which, since I like you guys, I feel like I should show you how to do that really quick. And like I said, this isn't really proportionally correct. I'm doing this rather quickly to illustrate, you know, how you would do this. So let's see if I can figure this out. So let's see, we're gonna need this curve. We're gonna kill that, and we're gonna need a rails. So let's get our rails here. Yeah, that should be 2 there. Okay. And let's actually design our spine really quick, or not our spine. Let's design our cross tie. Make this normal. I'm gonna do this rather fast. So let's just go boom. And when you design this, when you become a professional, you will actually do the correct design intent. You will not skip all the stuff I'm doing. I'm just gonna make this look close enough. And we're just gonna go like, I don't know, like something like this. Just go like, we're gonna boom, boom, Boom. Make sure this is 90, which it's not. Make sure you're 90, which you are. You should be 90, and you are. There you go. We'll copy this. Okay, and then we'll just offset it all. Boom, boom, boom. I don't know how thick to make it. Does that look okay? Good enough for me. Okay. Then we got to get in the middle. It's kind of touching that rail. Just draw it right in the smack dab. You'll dimension it. You'll make it perfect. I'm not going to do that for this demo. We're just going to make it work. We're going to make it work. This is all for visualizing. We're going to mirror this over. Ta-da. Cross tie. Sweet. And then we're going to make it some thickness. I don't know, 0.1. Is that good enough? Oh no. You're the engineer. You'll figure out how thick you want it. There you go, cross tie. Now, you're like, oh, but my other rails are hanging in space. We'll get back to that in a second. So let's just turn this back on really quick. We're gonna make a surface, boundary surface between these two rails. And you're like, Matt, why would you do that? Well, hold on, just give me a second. We're gonna pattern this feature along the curve. So the direction will be on this direction. Features will be my cross tie just modeled. Face normal will be here, and there you go. Now we have our cross ties. And like I said, there's one other piece. We do need to connect the rails. But as you can see, like, look at this. This is actually traveling that distance. It is taking that up distance that we talked about, and it is moving, slowly going from 0 to 0.5 meters up this rail. And that is how you would model a 4D track section. And lastly, I'll show you what you can do. Everyone's gonna get mad at me that I didn't connect the rails, so let's do that. This takes a little bit of manual work, and we'll kind of touch on how you automate this in another video. Oh, we're gonna redo it. All right, so you make a plane. You're gonna go sketch on that plane. Every plane per cross tie. You go to tools, sketch tools, intersection curve. Select your rails. Hell, you can even select this. I don't think that'll work, but actually let's just deselect that. And there you go. So now in your sketch you have where those rails are in space, and then you can kind of convert, you know, ooh, we don't want that. We can just take this guy and this guy, so we have something to trace on. And then you just got to find the center of the circle. So just make sure you go perpendicular, which it should, ooh, not like that, but it should snack to the perpendicular. There it goes. So you got your perpendicular, and then you can just draw a line from here, and then just make sure everything's perpendicular. There it goes. So snap perpendicular, and then you just do offset. Make sure you cap your line. See what it's doing here. Make sure it's centered, and hit OK. Oh, I gotta mirror it, so let's do that really quick because it will be the same height on the other side. So I guess you only have to do it for one rail, not necessarily two. Just make sure everything's perpendicular, and it'll come out great. And you'll do great. There you go. Go the other way. Bam. Now you'll do that for the rest, and you will get your track section. And if you don't believe me that this is all one, let's just do a section view on it. As you can see, it looks great. So there you go. You are now one step closer to designing a 3D printable, or hell, even manufacturable 4D track that will then rotate. So in other videos, we'll talk about, you know, how you do like the rack and pinion calculation and whatnot. I think for this series, we're gonna dive into other track sections you can make using the principles we just learned. But I thought this was very fun, very informative way to make 4D track using data from nolimits, using equations that you can derive easily, understanding the principles of what comes out of nolimits. So with that, thank you for joining me. Please like and subscribe to videos. If this is educational and you like this, let me know. If I'm going too fast, let me know. If I'm going too slow, let me know. If I made any mistakes, also let me know. As I said, this is just how I would do it. It's not necessarily the right way, but it's a way. And hopefully this will provoke or prompt you to think of, you know, different ways to model track and 3D print stuff and whatever you need to do. So I'll see you guys in the next video. Peace.